Assalamu alaikum everyone. I'm Naeem Bukhari and today we will cover this atomic structure from this topic. Okay, so the table of content is we will cover atomic structure, electronic configuration, isotopes and ionization energy. And we will not only cover this topic by lecture, we will also solve their topical past papers. Okay, so here we have particle in atom or atomic radius. So it is actually the topic from atomic structure. Like in an atom, there's a nucleus in the center. There's a nucleus in the center, okay? And there are proton and neutrons in the nucleus of an atom, okay? And there are certain orbits, we know them. In your A level chemistry, they are also known as a principal quantum number. They are known as a quantum number, okay? Quantum number. If your quantum number represented by small n, if quantum number represented by n is equal to 1, it means there's only one shell. You can see it is our nucleus of an atom. It is the nucleus and it is the first shell. And the first shell close to this nucleus, it is lowered in energy, okay? And if we draw some other shell, here you people can see. So for this, n value will be equal to, it is equal to, n is equal to 2. Like if principal quantum number is 2, it means there are two shells, okay? So we people know there are proton number, and what is the proton number? Total number of protons in the nucleus of an atom, okay? What is the proton number or atomic number? Proton number. It is also known as atomic number, okay? Atomic number. So total number of protons, total number of protons in the nucleus of an atom, okay? Total number of protons in the nucleus of an atom. So for example, we have this magnesium, okay? So magnesium, how can we write it? Here we will write this 12. 12, it is representing its number, proton number, atomic number, okay? And if I write 24 here, it means there are 24 like nucleon number. So what is the nucleon number? It is also known as mass number, nucleon number, okay? Nucleon number. Nucleon number is actually a total number of proton plus neutron, okay? Nucleon number is total number of proton plus neutron is equal to nucleon number, okay? So for example, if there are 24, so it means there are 12 protons, there are 12 protons and nucleon number is 24. So how can we find the number of neutrons? It means 24 minus this proton number 12. It means there are 12 neutrons. There are 12 neutron particles, okay, in the nucleus of an atom. So let me make idea more clear for you people. I have this carbon. Okay, if I see atomic periodic table, you will notice there is 6 and there's a number 12. So it is representing nucleon number, it is representing nucleon or atomic mass, okay? Relative atomic mass, nucleon number, okay? And what about this? Here we have this 6. It is atomic number, and atomic number is total number of protons, okay? So how can I find out neutron numbers? If I want to find neutron number, so neutron number is equal to nucleon number minus atomic number, okay? Nucleon number minus this proton number, okay? Proton number. So how many nucleon numbers are there? Are 12 minus 6. So it means there are 6 neutrons in the nucleus of this carbon atom, okay? So let's solve some questions side by side from your past papers. So here we have a question May June 2024, the latest question, okay? So magnesium 2 positive. What is this 2 positive? 2 positive mean charge of 2 positive. It means there are 2 electrons less than actual magnesium. For example, if you have this magnesium and you are converting this magnesium into 2 positive, it means this magnesium is losing 2 electrons. Okay, when you remove 2 electrons from the magnesium, you will notice this sign 2 positive. Okay, so what is the nucleon number? It is 24, already given. So what is the proton number? So how can you figure out the proton number? You will go to this periodic table and you will notice here we have this magnesium. Okay, and you can notice there's a 12. It means there are 12 proton numbers. Okay, so there are, how many proton numbers are there? 12. So number of electrons, proton number is equal to electron numbers. Protons are equal to electrons. Is it clear? How many protons were there? There were 12 protons. But what I already told you, 2 positive mean there are actual 12 electron minus 2, because 2 positive is presenting 2 electrons or less. So it will become 10. So there are 10 number of electrons. Okay. So aluminum. So aluminum is actual atomic number is 13 and its nucleon number is 27, already given here. So how many proton number are there? So this atomic number actually represents number of protons, and you will find this from your periodic table. Okay, so number of protons are there 13. Okay, number of electrons. So here we can notice 3 positive charges there. It means actual electrons are 13 and positive 3 positive mean 3 electrons removed from here. So remaining electrons are 10. So you will write remaining electrons are 10. Okay. State and explain difference in the ionic radius of aluminum compared to magnesium. Okay. What's the ionic radius? Radius of an ion. For example, you have periodic table, and here we have this periodic table. Okay. So we have this hydrogen is radius, then we have lithium is at 2, period number 2, so 2 radius. Then we have sodium, there are 3 shells. Here we have these 3 shells. Okay. Then potassium, we will have this 4. So you people can notice down the group, when we are moving down, atomic radius increases. Okay, down the group atomic radius increases, but left to right atomic radius, left to right, okay, atomic radius decrease. Atomic radius or atomic radius decrease. Okay, when we move left to right atomic radius decrease, but we are talking about ionic radius. Okay, so here we have aluminum 3 positive and here we have magnesium 2 positive. If you check this here, you will notice this. Let me remove this first. We have aluminum here and we have magnesium here. Okay, and we are moving from left to right. What I told you, left to right atomic radius decrease. First reason is here we have 12 protons, here we have 13 protons. It means from left to right proton number increase. Okay, charge is actually increasing. Okay, so status explain the difference in the ionic radius of aluminum compared to magnesium. So aluminum, it means aluminum 3 positive has lower ionic radius. It has lower ionic radius. Why? Now he is asking for 3 marks. You have to explain. 1 mark for this, lower ionic radius. Then what is the reason? So left to right proton number increase. Okay, left to right charge increase, a proton number increase. Okay, left to right, proton numbers increase. And what is the effect of this proton number? Proton number increase. So the forces of attraction between the nucleus and the outer electron increase. Okay, so attraction between nucleus and outer electrons, outermost electrons increase. Okay, electrons increase. Understand? Next is the elements silicon, phosphorus, and sulfur are in period number 3 of the periodic table. Describe the variation in atomic radius from silicon to sulfur. So you can check this here. We have this period number 1, we have this period number 2, and we have this period number 3. Okay, and here we have this aluminum, silicon, phosphorus, and sulfur from the same period number 3. And already I told you left to right, here we have 3 protons, here we have 14 protons, here we have 15 protons. So left to right proton number is increasing, so it means from silicon to the sulfur the size of atom decrease. Okay, size of atom decrease. So one more question. So variation atomic radius from silicon to sulfur, it decrease. I am writing decrease. Okay, he is not asking for some reason. Okay, okay, phosphorus 3 negative, sulfur 2 and chloride have same number of electrons. State the trend in ionic radius shown by phosphorus, sulfur and chloride. You can see we have this phosphorus here. Okay, so let me remove this. We have this phosphorus, then we are moving right hand side, left to right, then we have sulfur, and then we have this chlorine. Okay, so left to right their radius actually decreasing, left to right their radius is decreasing. Okay, so state the trend in atomic radius decrease. Okay, left to right decrease. Explain your answer. So left to right atomic number increase, like proton number actually increase. Okay, and forces of attraction between nucleus and outer electron increase. Okay, attraction between nucleus and outermost electrons. Okay, and outer electrons increase. Okay, no shielding effect increase. Why? Because left to right shielding effect remains constant, because there's no extra shell is being added. You know, when we move down, shell size increase, extra shell increases. Okay, when we move from left top to bottom. Okay, so you can notice inner electrons like this, we will have this, then we will have this. When you move from top to bottom, so these inner electrons, they also increase. You can notice this. Okay, top to bottom. Okay, but you are moving from left to right, so atom shell number will remain the same. Okay, they will remain 2 2. If there is a period number 2, period number 1 mean only one shell is there. Period number 2 means there are only 2 shells. Okay, let me explain you here. So it is the period number 1. It means this hydrogen and this helium, they both will have only one orbital. Okay, shell. If we have this period number 2, from lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, all these members, they will have only 2 shells, 1 and 2. Okay, so left to right number of shells remains constant. It is the reason from left to right inner electrons are shielding, it will remain constant. Okay, but top to bottom shielding increases. Okay, so we already have done this. So here we have next question. Where species such as ammonium, carbonates, phosphate, examples of molecular ions. Okay, now they're not single elements. Ammonium is a combination of nitrogen and hydrogen. Carbonate is a combination of carbon and oxygen. So now complete the table. So molecular ions are given here. Here, total number of protons. So you know in nitrogen atomic number is 7 and 1 hydrogen's atomic number is 1. How I know this? You can check this from this periodic table. Here we have this, let me remove again this. Okay, so nitrogen. Here we have this nitrogen. Here you can see its atomic number is 7. It means there are 7 protons. And here we have this hydrogen. Here we have only one electron. Okay, one proton. So there are three NH4. It is NH4 and H4 positive sign. Okay. So nitrogen means there are 7 protons plus one hydrogen have 1. There are 4. So it is 4. It means 7, 3, 10 plus 1, 11. So there are total number of protons are there 11. Okay. Total number of electrons. Okay, you know protons are number of protons are equal to number of electrons. But here you can see there's a positive charge. Positive charge mean if total electrons are 11 and one positive mean one electron is less. So there are 10 electrons. How many electrons are there? There are 10 electrons. Okay. So what about this carbonate? So carbon atomic number is 6. Carbon atomic number is 6. And here we have O3, O3, 2 negative. 2 negative. So one oxygen, if you check the periodic table, you will notice one oxygen proton number is 8. We have 3 oxygens, so 8 multiplied by 3. Okay. So 8, 24 plus 6, 32. Okay, plus 6 is equal to 32. So how many protons are there? 32. So there are 2 negative charge. Now it means there are 2 extra electrons. Okay. So number of protons are 32, number of electrons are 32. But 2 negative sign mean 32, negative mean there are 2 extra electrons. It will become 34. It is 34. Okay. Good. So next we have phosphate. We have this phosphorus. It has atomic number I think 15. It has atomic number 15. And we have O4. O4 and one oxygen atomic number is 8. We have 4, so multiply by 4. 32. 8 multiplied by 4 are 32 plus 15. So 30 plus 10, 40, 45, 45 and 46, 47. So it means there are 47 protons. Total number of protons are there 47. Okay. So 3 negative mean phosphate 3 negative. Electrons are so 47. So add 3 electrons. There are 50. Okay. I hope you people got this answer. So now we have this next. Next question is okay. Atoms with nuclei containing an odd number of protons tend to have a fewer isotope than those with an even number of protons. Okay. So number of protons. Okay. Here we have this razor. So I will remove this first. Okay. So now we need to find their number of protons and neutrons and so on. Number of protons. It is a gallium. So check the periodic table. Here we have this gallium. It's a germanium. It's a gallium. So there are 31. Proton number is 31. It means there are 31 proton and 31 electrons. Okay. Gallium. Number of protons 31. Okay. From the periodic table. Okay. Number of neutrons. So it is 69 minus 31. Okay, how to find number of neutrons? 69 minus 31 is 8 and 38. Okay, so number of neutrons are there 38. Okay. Okay, next we have number of electrons. So you know number of protons are equal to number of, so how many protons are there? 31. So it means there's no positive or negative sign. Yes, there's no positive negative sign. The number of electrons are there 31 because number of protons and electrons are similar. Okay. So now we have gallium and the number of protons are similar 31 and the number of neutrons. Here we have this 71. So 71 minus 31, 71 minus 31, 0, 4. It is 40. Number of neutrons are 40. And number of electrons they are still similar. Okay. Calcium, magnesium, and radium are group 2 elements. Radium follow the same trend as other members of group 2. Okay. Here we have this magnesium at 25 and 12. Okay. It is 25. Okay. Nucleon number is 25. Atomic number is 12. Determine the number of protons and neutron in an atom of magnesium. Okay. So number of proton. You can see here from here it is number of protons are 12 and number of neutrons. So 25 minus 12. 25 minus 12. Okay. So it is 3 and 1. So there are 13. I hope you people are understanding these questions. Okay. We already know like electron carry, electron is a particle which carry negative charge. Proton in the nucleus of an atom, proton is carrying a positive charge. And what about the neutron? Neutron carry no charge. It is neutral in nature. Okay, it is neutral. So here we have source and source of electron, protons, and neutrons. Charge on plate. You know, proton is a positive charge. So it is attracted towards the negative. So it means the charge on plate is negative. It means the charge on plate is negative. Okay. So next we have this electrons. You can see electrons are negatively charged and they must be deflected towards some positive plate. There is a positive charge. Okay. There is a positive charge. So complete the diagram with the relative charge. Okay, already we have done this. On the diagram, draw a line to show how a separate beam of neutron. You know, neutron has no, it is a neutral, no effect. So neutron beam will move straight. Okay, to move, sorry, straight. Okay, it is not deflected either this side or this side. Okay, because it is a neutral particle. Gallium is a metal. Okay, here we have this. Okay. Gallium is a metal in group 13 of the periodic table. There are two stable isotopes of gallium. Okay. State with reference to subatomic particle how the isotope of gallium differ from each other. You know, both the gallium have same like proton number 31. We already done this here. You people can notice number of proton here and here. They both have same number of protons, but their number of neutrons are different. How to define isotope? Isotopes are actually atoms having same proton number but different nucleon numbers. Okay, even sorry, you can say just right, different neutron numbers. Okay, so here you can see number of neutrons are different but number of protons are same. So you will write they have different neutron numbers. Okay, they have different neutron number. Okay, different neutron number. The different neutron numbers. Number of neutron is different. Okay? A sample contain three different types of, here we have this argon, krypton, and calcium. Okay, and this similar, the same they element have same nucleon number 40, 40, and 40. Okay, state fully in terms of number of subatomic particles what these three atoms have in common. Same, they have same nucleon number. Okay, same nucleon number 40, 40, and okay. To state fully in terms of the numbers of all subatomic how these atoms differ from each other because they have different neutron number. They have different neutron number. Even you can say different proton number. Okay, different proton and neutron numbers. And you can notice their proton numbers are different. Its proton number is 18, then 19, then it is 20. Okay. So we have next question. It is related to electronic configuration. So first I will teach you what is electronic configuration. Second, electronic configuration is actually arrangement of, it is actually arrangement of electrons in shells and subshells and subshells of an atom. Okay, it is actually electronic configuration. There are certain rules for arrangement of these electrons if you are assigning. Okay, so number one, we can say fill electrons from the lowest energy shell. If you have electrons and you are filling them, so choose always the lowest possible energy shell. So, like filling of electron, there are three shells. You can say it like lowering energy, lower energy shell fill first. Okay, number one point. Number 2 point, if you have same subshell, what are subshells? There are S, P, D, and F. They are actually subshells. They are the subshells. Okay. And for example, you have this S. It can maximum accommodate 2 electrons. S can maximum have 2 electrons. Now plus 4. Add 4. So 2 plus 4 becomes 6. It means P maximum can have 6 electrons. It can have maximum of 6 electrons. Now add further 4. 6 plus 4 become 10. So it is D. So D maximum can accommodate 10 electrons. Now add 4. 10 plus 4 is equal to 14. So F subshell, it can maximum accommodate 14 electrons. Okay. But in your A levels content, we will remain this till D. Okay. There's no like configuration of F subshell. Okay. So if we talk about their shapes, S, it is spherical in shape. If I draw this draw this axis, x-axis is y-axis, and if I draw the axis, okay. So the shape of S is spherical, and it is similar across all the angles. Even you can see in all the directions. Okay. So shape of S is spherical in nature. And what about P? You will notice P is like, if P is on x-axis, so you will write it here, dumbbell shape, x-axis, Px. If P is available on the y-axis, here, like this, it is the z-axis. Okay, so it is known as a Py. If P is available on z-axis, for example, if I draw z here, z, okay, it is known as Pz. So there are three subshells of P, Px, Py, and Pz, and all the three have same energy. Okay. So what about D? Okay, so D, they have actually 5 subshells. D have, you can write these things, okay, side by side, because of course I need some space for writing these things. Already I have a less space. Okay. If we talk about D subshells, so there are 5 D subshells. Okay. So dxy, first is dxy, second d xy, yz, xz, and dx square, y square, and the last one is dz square. Okay. So they all are important. Okay. So P, Px, Py, Pz only. And what about D, dxy, yz, xz, x square, y square, and dz square. Okay, how to draw these shapes? Okay, now I'm drawing this xy. So here I have this y-axis, x-axis, I have this y-axis, and now I have this z-axis. Okay? Z. So xy, it means it is on this x. Sorry, my bad. Write them in between the axis, not on the axis. Okay. Well, sorry. Not on the axis, between the axis. So here I have a xy. Okay. So here I have this x between this x Oh, my bad. Drawing. And Y mean there's a in between this here. Okay. YZ mean you will put it here between this Y and then between this Z. Okay. In between. But if you draw these, that you need to draw them, for example, X square, Y square mean you will bold them. Okay. The Z. So X square mean you will draw here, but you are bolding it multiple times. Okay. And Y square, sorry, not on the axis. Sorry, really sorry. Not on the axis, between the axis. So once again, sorry, these two are on the axis, on the axis, on axis. If you draw these two on axis, if you draw these three in between axis. Now I'm this to draw on the axis but in bold form because X square, X two times, so bold it. And Y is here, so bold it on the Y. And how to draw DZ? DZ is here on D axis, put this circle here. Okay. Understand? If you draw the DZ, to draw this shape and put. If he is not asking, like if he is not providing this axis, you can simply draw them like this. DZ, you will simple draw this, okay? You will draw this like this, and you will put a circle around it. It is representing this Z, okay? I hope you got a little bit idea about. So when you're filling, so the first point is lower energy shell phase first. Okay, you will fill it first time, very fast. Okay, initially. Second is no two electrons can have same spin in same subshell. Okay, no two electrons, no two electrons no two electrons can have same spin in same shells. या दफा हो जो काम कर रहा हूं are subshell. For example, if I have this, if I have this px, py, and if I have this p. Okay, so now I have two electrons. So I will like put them in this direction and two electrons. So it is actually there are two. It is representing two electrons, and one is like above, like it is spinning in anti-clockwise, counterclockwise direction. Another could be in clockwise. So never put them. If, for example, if you're putting them like this, it is a wrong. Okay, so you should not write in this way. You should put them in this way. Okay, and other thing is you will never put electrons together. First, you will put electron here in this pin, then here, then here. And still, if you could think like you have some extra electrons, so you will fill them again from the beginning. In opposite spin, you will put first here, then here. If you don't have any electron, so you will leave this PZ. Okay, so it doesn't mean if you have electron and you're directly filling them 2, 2, and 2. It's a wrong method. Okay, so first thing is you will fill electron in the lowest energy. Then other thing is if you are putting two electrons, there must be an opposite spin. Okay, because when they have opposite spins, opposite directions, they will like cancel out their magnetic fields. Okay, so now let's solve the question. So here we have this question. Determine the full electronic configuration of Fe3 positive. Okay, so now we have this Fe3 positive. So first we need to find atomic number of iron from the periodic table. And here I have iron, and we can notice it is 26. Okay, so 26 mean there are 26 electrons. So 1s2, 1 mean orbit number shell number 1, s2. There are 2 electrons in the first shell. And 2s2, 2p6. Then the orbit number 2, shell number 2, like 2. It can have maximum 8 electrons. 6 plus 2, 8. Now it is completely filled. Now I'm moving towards the next one. Okay. So 3s2, 3s2, 3p6, and now 3d and 4s. 4s is lower in energy. It is the reason we will fill first 4s, then we will fill this. I have this razor. I am writing in this fashion for making idea clear. I am filling 4s. I am writing 4s first, then I am writing 3d. Why I am writing 4s first? Because it is lower in energy than 3d. I already explained you. You will fill electron in that shell or subshell which is lower in energy. Okay, we have 26. Okay, 4s2, 6, 6, 12, 12 plus 2, 14, 16, 17, 18, 18, and still we have 18, 90, 20, and 7. It is 7, I think. Okay, 6, 6, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 6, not 7. But here you can see it is 3 positive. 3 positive mean 3 electrons are less. So you will remove first 2 electrons from here. Keep in your mind. When you are filling it before 3D, you will fill 4s first. If you are removing electron, you will remove electron from 4s first. Okay. So now I am removing 3 electrons. So 2 electrons from here and 1 electron from here. So it will become 1s2, 1s2, 2s2, 2p6, 3s2, and 3p6. Now 4s0, 4s0, because 2 electrons from here. It is 3d6, it will become 3d5. 3d5. 1 electron from here and 2 electrons here removed. Understand? It is your choice. Even you can write it or not. Even you can write 3p6 and 3d5 on. Okay? Or 3 positive. P3, S2 and chloride have same number of electrons and give the full electronic configuration of phosphorus 3 negative. Now we have this P3 negative. So now what is the atomic number of this? I know, but for your convenience, you can check it is a 15. Okay, it means there are 15 electrons. So first I will write the configuration of simple P. It is 1s2. There are 15 electrons. 1s2, then 2s2, and 2p6, 3s2, and then 3p. 15, 6 plus 2, 8 plus 2, 10 plus 2, 12, and there are 3. But we have 3 negative. 3 negative mean 3 electrons or more. So now I will write for this 1s2, 1s2, I will write it 2s2, 2p6, 2p6, 3s2, and 3p6. 3p6. Why I am added 3 6 here? Because the 3 negative mean plus 3 electrons. It will become 3p6. Okay. Tellurium is an element in group 16. The most common isotope of tellurium is 130 nucleon number. Its electronic configuration. Okay, what krypton means? It is a noble gas. If you check the electronic configuration of krypton, like from the beginning 1s2, 2s2, 2p6, 3s2, whatever. So the first till krypton, electronic configuration of tellurium till krypton is completed. Now he is writing only the valence shell, the outermost electronic configuration. He is only explaining this like 4d10, 5s2. Identify the subshell in atom of tellurium that contain the electron with the lowest energy. So what I told you, this is the lowest energy. The first shell is always the lowest energy, then higher, then higher, then higher. Because we are filling electrons from the lowest energy to highest energy. So 1s, you can write it here. 1s is the lowest possible energy. Okay. When potassium iodide is added to copper sulfate, the blue colored solution turns brown and white. Okay. The reaction between copper ion and iodide form only two. State the full electronic configuration of copper 2 positive. So now copper from transition, you can see copper here, atomic number 29. Okay. It means there are 29 electrons. Copper, Cu, 29. So first I will write this for this because it is from transition element. So I need to carefully remove two electrons from the 4s. Okay. So first I will write the configuration of this 29. 1s2, s2, 2s2, 2p6, 3s2, 3p6. Now 4s, 2 and 3d. How many electrons are there total? 6, 6, 12, 12 plus 2, 14, 15, 16, 17, 18, 19, 20. Remaining I have 9, so it will become 3d9. But he is now giving me 3d2 positive. It means I will remove 2 electrons from here, 4s2. So the configuration of copper 2 positive, copper, it will become 1s2, 2s2, 2p6, 3s2, 3p6. I'm not writing because it is 0, 4s0, because electron removed from, then 3d9. 3d9. Even you can check this if I made any mistake, but I'm sure I'm writing this. So right now, okay, from here. Potassium also has two stable isotopes. Both isotopes have the same chemical properties. State the full electronic configuration of atom of potassium. Okay, so atom of potassium. You can say it is a potassium. And what's the atomic number of potassium? Check this. Potassium here. You can notice 19. Okay, atomic number 19. So it is 19. 1s2, 2, 2s2, 2p6, then 3s2, then 3p. 19 are there. 6 plus 2, 8 to 10 to 12, and 3 plus 6, 18, and then a 4s1. 4s, it is electronic configuration. You can write this thing here. Okay. We have this bromine, and first we need to check its atomic number, how many electrons are there in the bromine. So bromine atomic number is 35. Okay, it means there are 35 electrons in the bromine. So I'm writing the full configuration of bromine for your practice. I have this bromine, atomic number is 35. Okay, so it is 1s2, 1s2, 2s2, and 2p6, 3s2, and then 3p6. Okay, and now once we have this next 3d 4s. Okay, and 4s, and then we will have this 3d, and then we will have this 4p. So we have 35 electrons. Okay, so 6 plus 6, 12, 12 to 14, 15, 16, 17, 18, 18 plus 2, 20. So I'm writing it here like I have completely filled 20 electrons still. Now we have remaining 15 electrons. Okay. So in 15, you can say 3D maximum can have 10 electrons, and 4p can have maximum of 5 electrons. Okay. So we need to write this configuration of 4s2, 3d, and okay. So here we have like 3d, and we have this 10 electrons. So I will write it here first, like 1 electron, 2, 3, 4, 5, and still remaining we have 5. So I will write it here 6, 7, 8, 9, and 10. So you are noticing I didn't like completely fill like double double, no. First I wrote 1 1 1 1, and now even you can see like I am writing in opposite spins. Okay, so no two electron can reside in the same orbit with same spin. Okay, you should people write in opposite spin. Okay, Here I have 4s2, so 4s2 here in opposite spin. Understand? Now I have 4p5. I will write it here 1, then 2, then 3. So still I have 2 electrons. I will write the 4 and then I will write it here 5. It is the final electronic configuration of this, and I hope you people are getting some idea. Okay. So calcium, magnesium and radium are group 2 elements. Radium factors follow the same trend as the other member of group 2. Identify the highest energy orbital which contain electrons in calcium atom. Sketch the shape of, okay. So now we have to find the highest energy. Lowest one is, 1s. So now we will find the extremely like outermost shell. Okay. So it is a calcium. So what is the atomic number of calcium? I think it is 20. Yes. So now I need to write this configuration to figure out which one is the at the end. Okay. I'm writing it 1s2, 1s2, 2s2, 2p6, then 3s2, okay, and then 3p6, 3p6, 20, 6, 12, and 12, 14, 15, 16, 17, 18, 19, 20 mean 4s2, 4s2. Is it? So as you people know, 4s is lower in energy than 3d. Okay. So the which one is the like highest energy? It is 4s. Identity of highest energy orbital in calcium 20, 6 to 12, okay, 12 to 14, 15, 16, 17, 18, 19, 20. Yes, I need to fill this for 4s. So it means 4s. It is 4s, highest energy. And what is the shape? S shape is spherical in nature. Its shape is spherical in nature. Okay. State the full electronic configuration of atom of magnesium. Okay, next question is magnesium atomic number 12. So it is very simple and easy. I can write it here 1s2, 2s2, 2p6 and 3s2. 3s2. So it is 12. So there are 12. Okay. An isotope of copper has a relative isotope mass of 65, complete table 1.2. Okay, so copper has 60 atomic number. So we will check atomic number from the periodic table. And here we have this copper. It is the copper 29. Okay, you can check this 29. Okay, atomic number of copper is 29, and the nucleon number here you can see it is a 65, already mentioned. Okay, number of neutrons, so 65 minus 29, 65 minus 29, 6, and 5, and 5 minus 2, 3, I think 36. Please check this again, I'm not good in mathematics. Okay. 36. Electronic arrangement. So how many number of protons, atomic number are there? 29. Electronic arrangement according to this 29. Okay. So we will have this copper and 29. I will write the configuration like this: 1s2, 2s2, 2p6, and then 3s2, 3p6. Okay, and then 4s2, and then 3d. They are 29. So till now I have done this. There are around how many? 20 electrons. Now I have remaining 9. So even I can write this in other way. For example, I can write this 4s1 and 3d10 as well. Why? The level of stability, criteria of stability is like these two. They must. The first thing is completely filled. Completely, completely filled. For example, if you have this condition 4s2 and 3d10, so it is the highest stable one, highest stability. Like for S maximum can have 2 electrons, D maximum can have 10 electrons, so they are completely filled. Okay, the first like criteria for stability is they must be completely. Other is half filled. Other criteria is half filled. Half filled. Okay, half filled mean like you have 4s1 and 3d5. Remember, half of 10 is 5, half of 2 is 1. So if I wrote this like this configuration 4s2 3d9, although it is completely filled, but if I'm writing it here, I'm completing this 3d10 and still I'm keeping it half filled. It become completely filled and it will become half filled. So it is the filling the second criteria of stability. So please you people should write this, okay? 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1, then 3d10, okay? Okay, next. I will write, you need people need to write it here, okay? So next we have this question. Here we have ionization energies are given. Deduce the full electronic configuration of E. Explain your answer. Full electronic configuration of E. Okay. Let me remove this first. You people can notice we have 577 first ionization energy, then second, then third, but fourth is the biggest. You can notice it is just 2740. Fourth one is the 11,600. It means it is E is some atom like it has this type of configuration. It has 3 electrons, 1, 2, 3, and 8, 1, 2, 3, 4, 5, 6, 7. It means when you remove this electron, it will release 577 amount of energy required, not release required, okay? If you release the second electron, it required 1820. If you remove third electron, 2740. But fourth one, like if you remove the inner electron, it means there are 3 electrons in the outermost shell of this E. So full electronic configuration, I'm just writing it here till like 3p or something. Okay. So 1s2, 1s2, 2s2, 2p6, and 3s2 and 3p1. So it means these 3 electrons, okay, from this orbit number 3. So when you remove first electron, this, it will release 577. When you release 3s1, 1820. When you release 3s2, 27. But when you are entering into this 2 orbital, it will release, which is the like finest electronic configuration for this. Okay. Explanation: there is a great jump between third and fourth ionization energy. Okay. Space is less, huge, huge energy gap, huge energy gap between this third and fourth, third and fourth ionization energy. Okay. Okay, separate 1.0 gram sample of 3 different magnesium salts are tested. Okay, questions: complete the electronic configuration of the magnesium cation present in this salt. So, magnesium cation, you people know a magnesium is from group 2 and its cation will become 2 positive. Atomic number of magnesium is 12. It means there are 12 electrons. So 2 positive means 2 electrons are less. Okay. So it will become 1s2, 1s2, 2s2, 2p6, and 3s2. Okay. So it will become, if 2 electrons are removed, it will become 1s2, 2s2, 2p6. Okay, it is the electronic configuration 1s2, 2s2, and 2p6. 2p6. Okay. So electrons in the atoms used. Okay, here we have krypton and it is topic number 36. Okay. Okay, the type of orbitals. How many type of orbital S are there, P there, and D is. So we have this krypton. So let me check this atomic number again on the periodic table. Krypton, here we have it is 36. Okay, the big, okay, number of occupied orbitals. Understand? So you can see it is like 1s, it is 2s2, like S1, 2, it is also S3 and 4. So S orbitals are, number of S orbitals are there 4. Okay. And now we will find occupied p orbitals. 2p6, you can see like p is equal to px, py, pz. 1p is equal to px, py, pz. Okay, you have 2p6, 3 and 3p6 and plus 3, 6 and this 3. Like I'm writing it 2px, 2py, 2pz and 3px, 3py, 3pz and 4px, 4py, 4pz, 4px, 4py and 4pz. So 3 this and 3p6. Here we have this 3px, 3py and 3pz. 3 6 p orbitals and plus this 2px, 2py. So there are p, there are only 9. Okay. And what about d? D10, it is completely filled. So you know, I told you like this dxy, dyz, dxz, dx square, y square, and d. So 1, 2, 3, 4. They all are completely filled because there are 10 electrons. So 2 here, 2 electrons, then 2 here, 2 here, 2 here. So there are d is equal to 5 orbitals. S is equal to 4 and p is equal to 9 and d is equal to how many? They are 5 occupied orbitals. Okay, orbitals, understand, not subshells, see orbitals. Okay, complete the diagram to show the number of and relative energies of the electron in an isolated atom of silicon. To show the, okay, silicon atomic number 14, here I have this. Okay, so silicon is here, atomic number 14, it will become 1s2. Okay, 1s2, 2s2, 2s2, 2p6, then 3s2 and 12, and then we will write it 3p. There are 14 electrons, 6 plus 2, 8 plus 2, 10 to 12, 3p2. Okay, so now 1s2 already filled is here, 2s2 mean 2 electrons with opposite spin, and 3p6, 1, 2, 3, 4, 5, 6, 3s2 with 3s2, and then 3p2, 1 electron here and 1 electron here. If you write it here just like this, for example, and 2 electrons here, it will become wrong. It is against the rules of filling electrons. So first independent. Okay, it is the electronic configuration. Here the total number of electrons that exist. Sorry for this. Okay. Okay. State the total number of electrons that exist in all orbitals of this type in an atom of F9, fluorine 9. So 1s2, 2s2, 2p6, 2p5. Okay, because it's 9, 5 to 7 and 2 9. Okay, so how many orbitals are fully occupied like this? Okay, so it is 2px, 2py, 2px, 2py and 2pz. 5 electrons are there, 1, 2, 3, 4 and it is 5 electrons. So 2 electrons are completely filled. I can write it here, there are 2. Please check this. Okay, lithium hydride contain the lithium and okay hydride. State the electronic configuration of these two ions. So atomic number of lithium is 3. Lithium, it is positive charge. Atomic number is 3. It means 1s2, 1s2 and 2s1. But one of the electron is removed from here, so I will write it here 1s2. It is 1s2 where it is lithium 1s2. And what about H negative? You know hydrogen is from group 1, atomic number 1. It is 1s1. But there's negative charge on the hydrogen, so it will become 1s2. Both they have same electronic configuration. Okay. Question number 15. Complete the table which describe a gaseous atom of gallium. So what is the nucleon number? So you can see it here. It is the nucleon number 71 is here. Total number of electrons in lowest energy levels. Lowest energy level. You know 1s2, there are 2 electrons in the lowest energy level, 1s2 is okay. Type of orbital which contain the electrons in the highest energy level. It is the gallium, and we already solved this gallium question, I think. Gallium is here, yeah, atomic number is proton number 31, and if there is 31, so now we need to configuration of this 31. No problem, not a problem for me, even for you. Okay, so now we are following gallium 31. Okay, to find the last highest occupied orbital. Okay, so here we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, now we have 31. Okay, 20 till here. From my knowledge, 20 electrons till here, and 10, 30, and then 4p1. So 4p is the highest energy shell. Okay. So type of orbital which contain the electron in the highest energy level, it is 4p, like p orbital. Okay, type of orbital is a p orbital. Okay, state the electronic configuration of a copper atom. I think we already have done this. Okay, in the periodic table, the p block contain element whose outer electrons are found in the p subshells. Element in the p. Okay, draw the shape of p orbital. So p orbital you can simply draw like this. Okay. So now it is from isotopes. Still, what is meant by the term nucleon number? The total number of protons and a neutron. Total number of proton and neutron in the nucleus of an atom. Okay. Total number of protons and neutrons in the nucleus of an atom. In the nucleus of an atom. Okay. Potassium also has two stable isotopes. Both isotopes have the same chemical properties. Explain why both isotopes of potassium have same, because they have same proton number. Even you can say they have same electronic configuration, because both they have same electronic configuration. Okay, same number of electrons, same electrons. Okay, in valence shell. Okay, because they have same electron number. Electron numbers are same, the proton numbers are same, but neutrons are different. And the reactivity of some element depends in number of electrons in the valence shell. Okay, same electrons in valence shell, same number of electrons in valence shell. Okay, a sample of magnesium contains 3 isotope magnesium. Okay, the percentage abundance. Okay, it is also given here. Okay, state one similarity and one difference in the properties of these isotopes of magnesium. What is the similarity? Like all they have same proton number. What is the different? They have different neutron number. Okay, similarity have they have same number of protons, same number of protons. And what is the difference? They have different nucleon number or number of neutron, different nucleon numbers. Okay, different. But nucleon numbers are, yes, different nucleon numbers. Even you can say they have different neutron numbers. Understand? Okay, hydrogen is a general term used to represent the ions. Okay, H, protium, deuterium, tritium. These are the 3 isotopes of hydrogen. Okay, state in terms of subatomic particle in the nucleus. What is the same about? Same thing. They have same proton number, same proton number, same proton number, and different nucleon number or different neutron. Even you can say. Okay, nucleon number. Even you can write they have different neutrons number. Okay. Next we have this question. Relative atomic mass. So it is, a relative abundance. Isotope with mass 78 exists in nature 23.77%. Isotope whose atomic mass is 80 exists in the nature 49.61%. Isotope whose mass is 77 exists in nature 7.63%. And isotope whose atomic number is 76 exists in nature 9.37%. Okay, so these are the relative abundance, relative availability of different isotopes. Okay, so relative atomic mass, it is the mass of an average mass of an atom, compare element and like average mass of, okay, relative isotopes, average mass of isotopes, isotopes of an element, okay, of an element. Relative atomic mass, okay, so what is isotope? Atoms of an atom, atoms of an element. Isotope is actually atoms of an element having same proton number, same proton numbers, but different neutron numbers. They have different neutron numbers. Okay, easy. Next we have this. Okay, we have this graph, and the energy value required to remove the first electron from an atom of argon is circled on here. You can see the first electron is circled here. Okay, the outermost electron which is being removed from argon. Sketch the shape of the orbital that contain this electron. Argon is from the p, so it is the p. Very easy. Okay. Next question, we have total number of electrons in a subshell of silicon. Okay, silicon, what is the atomic number of silicon? It is 14. So he is asking total number of electrons in S subshells. In S, only S. Okay, 1s2, 1s2, 2s2, 2p6, and 3s2 and 3p2. Okay, in S, how many are there? 2, and there are 2, and there are 2. So total number of electrons, there are 2 electrons, 2 and 2, 6. Phosphorus atomic number is phos P. Okay, in P, phosphorus, I mean, sorry, in subshells of P. So P is atomic number 15. So if I write it here like this, 3 phosphorus. So there, how many electrons? 2 to 4 to still 6. And what about sulfur? Still 6. Okay. Total number of electrons in P subshells. Okay. And when it was P2 for sulfur, there are 2 and 6 plus 2, 8. 8 here, and it will become 9, and it will become 10. Okay. Because 2p2, sorry, 3p2 is for silicon, 3p3 is for phosphorus, and 3p4 is, it will become for this sulfur. And already we have this 6 electron here, and 4, 6 plus 4, 10, and 6 plus 3, 9. Okay. So construct an equation represent the first ionization energy of silicon. Okay, equation. How to write the equation? Keep in your mind, number 1 point. Whenever you write any element in reactant sign, it must be in the gaseous state. In ionization energy, when you write some equation, that element must be in gaseous state. For example, I have this silicon. I will write this chemical reaction. Silicon in nature it exists as a solid state, but when you write ionization energy, you will write its gaseous, and it's losing 1 electron, removing 1 electron, and you will get silicon positive but gaseous atom. It is the first ionization energy for silicon. Okay. Three possible values for the first ionization energy P are given. So this side is missing. Okay. Okay, 106. No, it is lower. 760 is okay. Then 80. I think this one is a more accurate. In between this. Okay. Okay. Explain your choice, including a comparison of your chosen value for those of silicon and sulfur. Okay, why I wrote this 1060? Like, you know, left to right it increases, but here you can see it is 786, 786. Then its first ionization energy is 1060 as I predicted. And what about the sulfur? It is for sulfur, it is for phosphorus, and it is for silicon. It is 1000. So the question is why phosphorus has less ionization energy than, okay. If you check the configuration of phosphorus, it is atomic number 15, 1s2, 2s2, 2p6, 3s2. Okay, 6 plus 2, 8, 10, 12, 3px, 3px, 3py, and 3pz. One electron here, one electron here, and one electron. So what about this sulfur? Is just atomic number 16. It will become 3px, 3px, 3py, and 3pz. We have 16 extra electron. It will become one electron here, one here, and two electrons. So why phosphorus has low energy? Why it has low? Because you can see there's a inner pair repulsion. Okay. So number one, explain including a comparison of your chosen values to those of silicon and sulfur. Okay, so why I choose this 1060? There is a 1060 ionization energy value for what? Phosphorus, because there it contains three unpaired. You can see unpaired. Okay, contains three unpaired electrons, while in sulfur there is one paired electron, and because of their repulsion between these two electrons, it becomes easy to remove electron from the sulfur. Okay? And because of their repulsion and their repulsion make it easy to remove. Okay, I hope you people understand this. We have a question number 2, and it is similar to the question number 1. So you people can also practice of this question. Okay, if you understand the first one, then it is easy for you to figure out the question number 2. Okay, so construct an ionic equation to represent the first ionization energy of tellurium. So ionic equation, you know how to write this equation. First we write the element tellurium, but it must be in the gaseous state. Okay, and now you will remove one electron from here, and you will write it here tellurium in positive and gaseous form. Okay, two things are important. Number one, whenever you're writing this equation, your element must be in gaseous state, and when you are writing a product, it must be in the positive gaseous sign. Okay, sketch a graph figure to show the trend in the first 7 ionization energies of. So I already have done this. The reason is I don't have like direct values, so now I have to figure these values from this, I think from here. Oh sorry, it's not given here. Okay, so that's why here you can see there are two jumps, number 4 and 5. There's a jump between 4 and 5, but the highest jump is between energy 6 and energy 7. Okay, so you can even complete this by considering or by taking some values in front of you, then you can easily figure out this graph. Okay, so question number 4 is write an equation that represents the first ionization energy of hydrogen. So how to write this equation? Here we can say hydrogen in gaseous state and removing one electron, and it will become H positive gaseous ion. Okay, you will never write this. For example, hydrogen exists as a diatomic molecule. No, because if you see the definition of ionization energy, it is amount of energy required to remove electron from the valence shell of independent gaseous atom. Independent, it must be independent atom, but it is a molecule. Okay. So potassium, okay, explain why there is no information given in table 1.1 for the second ionization energy of H. You know, hydrogen has only one electron. It has only one electron. It has only one electron. Okay. H has, hydrogen has only one electron. Okay. It is the reason there is no information for other electronic configuration, second electronic configuration. Okay. Potassium also has two stable isotopes. Both isotopes have the same chemical properties. Okay, use the information explain why potassium is in group 1. New people can notice its first electron become easy to remove because its energy is lower, 4.418. But there's a great jump between first to second. Okay, you can say there is a huge energy difference between first and second. Between first and second ionization energy. Okay, ionization energy values. Okay, it is the reason. Okay, so define first ionization energy. Amount of energy, it is amount, sorry, minimum amount of energy, most accurate. Okay, it is minimum amount of energy, minimum amount of energy required to remove, because he is saying first ionization energy to remove first electron from the valence shell, from the valence shell of one mole of atoms, gaseous atoms, independent gaseous atoms. It is the reason I'm writing in every equation must be in gaseous and independent atom. I'm not writing them into the molecular form. Okay. So now we have this next question. Okay, use table 1.1 to use the group of the periodic table. Okay. So here you can say first energy is 1310, second is 33, and third is 53. It is gradually it is increasing. Okay. But in the fifth you can see there's a huge jump between fourth and fifth. So it means it is from group 5. It is from group fifth. Reason is because in group fifth you people can notice there's a big jump. Okay. Across period 3, okay, there is a general trend for first ionization energy to increase due to the increase in interaction between the nucleus and outer electron. Explain why the first ionization energy of sulfur is less than the first ionization energy of the phosphorus. I already explained you in here. You can see it here. You can see in sulfur there is an inner pair electron. Okay, their inner pair repulsion. Inner electrons pair repulsion. It is the reason. Okay, There's a in sulfur case you can see there's an inner, but in phosphorus all these electrons in the valence shell they are unpaired. So when they repel each other, it becomes easy for sulfur to take less ionization energy as compared to phosphorus. Okay. So next we have this. In an aluminum ion, the nucleus attraction for the outer electron is stronger than in an atom of sodium. Okay. So if you see like sodium in periodic table, sorry here. Okay. If we check this from here, this okay. So you will notice this here. Here we have this sodium, and here we have this aluminum. And left to right, it is period number 3. Sodium has 3 shells, aluminum also has 3 shells. So sodium has 11 protons, aluminum has 13 protons. So proton number in aluminum is higher. So it means there is a great forces of attraction between the nucleus and the valence electrons in aluminum. That's why the ionization energy of aluminum is greater as compared to the sodium. Okay. Now we are just about to end our topic here. Okay, first is energies are given lithium, barium, boron, carbon. Okay, A is for you can say it is a March 2022 paper. Constant equation to represent the first ionization energy of oxygen. Okay, oxygen first O as an atom, single atom, independent in gaseous state. It is removing its first electron, and we will get this oxygen positive gas. Okay, ion. Okay. State as plain the general trend in the ionization energy across period 2. You can notice it is increasing. Generally, it is increasing. Okay, generally, ionization energy increasing. Generally, okay. Why it is increasing? You know, number one reason is left to right proton number increase. Okay, left to right. Number one reason is proton number increase. Okay, gradually. Number one. Because of this proton number increasing, forces of attraction between nucleus and outer electrons increase. Okay, forces of attraction, forces of attraction between the nucleus and outer electrons increase. Okay, increase. Okay. Explain why ionization energy A in figure does not follow the general. Here we can say oxygen and nitrogen. It must be in higher, but you can it is lower. Listen, if you check the electronic configuration of nitrogen atomic number 7, 1s2, 2s2, 2px, 2py, and we have this 1s2, 2s2, 2px, 2, 7. So 1 electron and 2px, 1, 2py, 2pz. And what about this oxygen? Here we have 8, 1s2, 2s2, 2px, 2py, and 2pz. Here you can say 1, 1, 1, and here I will have this 2. So this inner pair electron repulsion, you can notice it is the reason in A there is, you can say there is inner pair electron repulsion. That is why A has lower ionization energy as compared to the nitrogen. Okay. So you people can check this question. Please write down this question and you can take the screenshot of this and please solve this question. And you people should write the answer of this question in your like comment section. If still you people have any problem in this question, then I will help you with that. Okay. Thank you very much. Goodbye.